Good morning, everyone. In this lecture, we are going to discuss some more basics on from this network theory subject. But previously in lecture 1, I have introduced what is a charge, current, energy, and voltage. So charge, so it is for a negatively charged, that is negative for electrons. Q is equal to 1.6 into 10 to the power minus 19 coulomb, and it will be positive for positively charged particles. What is a current? Current is equal to I is equal to dq by dt. Whenever there is a charge motion within a particular time, so that is dq by dt is a flow of current, right? And if I want to find the charge accumulated, or what is the charge present from the at the instant of time, so we need to integrate the current I, right? So it's a rate of net motion of charge, right? So it's nothing but the current. Now, what is a voltage? So voltage is defined as the work done per unit charge. So when we are doing some work to move a unit charge from that particular instant, so what is the work done is called the voltage V. So dW by dQ. So the work done per unit charge. Now what is the power? So power is the energy, or what is the work per unit time. So how much energy you lost per particular work and how much you spend at time. That is P is equal to dW by dt. If I want to find the total energy at the instant of time, so we need to integrate the power. Right? So this is we discussed in the lecture 1. Now we are going to discuss the basic concept, how the current flow through the conductor, or what is the current direction. So depending on the direction, we need to, this total circuit theory will depend on these directions only. So that's the reason why we need to know this one, right? So the mechanism of current flow through the conductor. Suppose if I am taking any conductor, so copper, aluminum, and gold and silver, etc. Now any material will have the conductor means it should have some conductivity sigma. So sigma is the conductivity of the material. And this indication is, this is the electron, so this are indicating free electrons, right? And this is positively charged immobile ions. So positively charged immobile ions. So there is a mechanism. Suppose if the electron is moving from this place, so it will leave behind the positive charge, and it is the negative charge is removing, means it will become positively charged. But those positively charged are immobile, so they cannot move. Only free electrons can move, right? Now suppose and it is having some cross-sectional area, etc. So what is the current density is J is called current density, that we will see later. Now suppose this is a conductor. Suppose from the generator, if you apply some electric field, or generally in the later we will say voltage, if you apply some electric field or force, right, the electrons will try to move randomly, right? So they will get some energy and to move, so they try to move randomly, but so different. So the moment we apply electric field E, so they will go in different velocities, right? But we need to take the average velocity of all the electrons, that is called drift velocity. So Vd is equal to mu into electric field E, so, right? So this is the average momentum of the electrons, or we can say drift velocity, or average velocity of electrons, free electrons. Remember, always free electrons only can move, right? Not bounded electrons. So free electrons. So average velocity of free electrons, which will be proportional to the applied electric field, right? So Vd is proportional to applied electric field, and the mu is proportionally constant. So mu is generally called mobility of this conductor, or we can say free electrons, right? So mobility of free electrons present in the conductor. Now we need to see what is the units for mobility in the electric field. Now, so electric field E is equal to, generally it is defined by the voltage per unit length, right? So even though we are applying the electric field, if we are applying that electric field per unit length, right? So, or we can say V is equal to E into L, right? How much we apply the electric field across the length, so multiplication will get electric field, voltage. So electric field units are volt per meter or volt per centimeter, right? So this is one. And what is the mobility? This notation is mu is equal to Vd into E, right? So it is either meter square by volt second or centimeter square by volt second, right? So that also we will see. And what is the Vd? The drift velocity units are simply either meter per second or centimeter per second. So this is SI units and this is other units. Now, so how we got this is, suppose Vd is equal to mu into E. So there is a proof. So Vd, so we need mu. So mu is equal to Vd by E. So this is meter per second and this is volt per second. This is volt per meter, not second, right? So meter by second into meter by voltage is nothing but meter square by volt second or centimeter square by volt second. So electric field, always remember volt per meter or voltage per unit length, right? So that is about the units. Next we will see the current direction, right? So what is the current direction? Now if I take again this picture, next we will see the current direction. So in any conductor or any material, we will see, suppose this is the conductor. Suppose if we apply an electric field, that is we previously discussed. So when we apply electric field, the free electrons will get different velocities, and we will take the average of the free electrons. So that is Vd is equal to mu into applied electric field, right? Now if I apply electric field, so the electrons will try to oppose this applied electric field. That means when the electric field is in this direction, the electron movement will be in the opposite direction to oppose the applied force or applied electric field, right? Now what is the current direction is? Current direction is always opposite of this electron movement, or we can say in the direction of the electric field always, right? Or we can say in the direction of positive charges. So if electrons are moving in this direction, that is negatively charged, the positively charged ions will move in the same direction as the electric field, right? That is the conventional current. In opposite way, suppose this is a generator here, suppose which is generating the, we can say, electric field, suppose, and this is a conducting material, conductor with conductivity, etc. Now if I apply some electric field in this direction, right? So this is grounded, so the electron movement will be in the opposite direction, right? So this is the electrons movement opposite of the applied electric field. So this is E. Now what is the conventional current? Is the current direction is opposite of the electron movement, that is the current direction is like this, opposite of the electron movement, or we can say in phase, or we can say in phase with the electric field, or in the same direction as the electric field. So that is the reason when we take any circuit, right? So it may be generator, so electric field or voltage, whatever, so many resistors, so it R1, R2, R3, etc. So always with the conventional current from the source, this is the source, right? So always is the out of the positive terminal, right? So remember this point, always out of the positive terminal. So the reasons are, so what we mentioned here, right? So when we apply electric field, the electrons will try to oppose that electric field, right? So that is the movement of the electrons will be opposite of the applied electric field, right? So that is about the current direction. Next, so we have to define some more terms, that is, so what is the current? Current is nothing but I is equal to dq by dt in form of equation, that is the net rate of charge, the net rate of charge motion, right? That is I is equal to dq by dt. Now what is the density means? Density means the current density is equal to the current per unit area A, right? So this is area A, because the units are ampere, so this is A and this is also A, so that's why we'll go for cross sectional area S, right? So to avoid misconception, generally amperes for A. So the current density J is equal to I by S cross sectional area. S is cross sectional area. So what is the current direction? It is the in phase with the electric field and the same direction of the electric field, right? Or we can say opposite of the electrons. So if the electrons are moving in this direction, the current will be opposite. So when I find the current density, and always I told you, whenever the charge is moving from one place to another place, there is a charge conservation, so it will be neither created nor destroyed, it only transferable, right? So from one place to another place, suppose if it is here, so it will be come back again, so again and again, right? That's why we are talking about the cross sectional area, so here or here, right? So it is moving some cross sectional area, so that's why we are finding the current density J. So J is equal to current density, and which is amps per meter square or amps per centimeter square. These are the units, right? Amps per meter square or amps per centimeter square. Now again we need to define some more terms. So the main is Ohm's law, right? So what this Ohm's law states that the current density is directly proportional to the applied electric field, right? So if we varying the electric field, the current density also varies. So if I make it equal, we will get a proportionality constant, which is sigma, and J is equal to sigma E. This is the Ohm's law, first form of Ohm's law in field theory. So this is in field theory, not in circuit theory, right? So this is J is equal to sigma is Ohm's law in field theory. So there is a limitation for this Ohm's law. What is the limitation is the proportionality constant sigma should be constant, then only this proportionality will exist. So when I apply electric field, the current density should be in proportionality, should raise or decrease, right? Now when that will happen? When the sigma is always constant. Now how to make sigma constant? The only thing is temperature should be constant. So temperature should be constant, because depending on the temperature the sigma will vary, right? How, that we'll see, right? So the Ohm's law statement is like this: when the temperature is constant, when you apply electric field, right, the current density is also increases proportionally. So that is a Ohm's law statement in field theory, right? So we can say this is the first form of Ohm's law. Ohm's law in field theory. So J is equal to sigma into electric field E. Now if I make J is equal to, so we will derive some expressions. So I by S is the current density, and sigma is conductivity, and what is E in terms of volt? So volt per unit length, that is V by L. Now if I find V is equal to I into, right, L by S into sigma, right? Or we can say V is equal to I into R. So this is second form of Ohm's law, right? So V is equal to I into R. Now from this expression, what is R? So R is equal to L by S into sigma. So what is the notations? Ohms. Our units are ohms, right? So this is the length of the conducting material. This is the cross-sectional area. Cross-sectional area, and this is the length of the conductor. Length of the conductor, and this sigma is conductivity of the conductor. Conductivity of the conductor, or generally we say material, right? Here in this case conductor. So conductivity of the conductor. Now other way we can write like this. So resistivity, one term will come which is called the 1 by sigma, right? So rho is equal to 1 by sigma, and rho is called resistivity of the material, resistivity of the conductivity. So resistivity, right? So we need to find the some units for sigma. So sigma is equal to, so this is generally 1 by ohm meter, or we can say Siemens per meter. This is SI units, so Siemens per centimeters in the other units. Similarly, what is the rho? Rho is equal to 1 by sigma. It will become ohm meter or ohm centimeter in other ones, right? Ohm meter or ohm centimeters. So here also Siemens per centimeters in the other units. So conductivity is Siemens per meter or 1 by ohm meter, and resistivity is ohm meter or ohm centimeter in other units, right? This is resistivity. So can I replace here the 1 by rho is rho, I mean R is equal to L by S into rho, and resistivity can be find R into S by L. So this is one more expression we need to remember, right? So rho is equal to R into A, I mean cross-sectional area, by L, unit length, right? R is equal to, we can say simple, rho into L by cross-sectional area. So any one you can easily remember, and you can transform to other form, right? So we have to remember the units also, right? So this is about the current direction and some parameters. Now we need to find the, again we have to come back to the Ohm's law. So what is the Ohm's law? In field theory, J is equal to sigma E. Now if I draw the J and E characteristics, suppose J is here and E is here, right? So at electric field is 0, and the current density should also be 0, and it should be passed through this origin. And what is the slope? Slope is nothing but sigma, right? And the sigma always constant in any this quadrant or this quadrant, so that's why it is called linear, right? So applied electric field, proportionally the current density also increases. So that is a Ohm's law in field theory form, right? So this is generally is called JE characteristics. Now what is the Ohm's law in circuit theory form? So Ohm's law in circuit theory form, so we have to remember this one. So many have some different concepts. So if temperature is constant, the current is directly proportional to the applied voltage, right? So current is the effect and voltage is the cause. So when we apply voltage, then depending on that voltage the current will change proportionally. So what is I is equal to V by R, or we can say V is equal to IR. This is the, that already I told, the second form of Ohm's law, right? And the condition is temperature should be in a constant, right? Or this is also can be written like this: I is equal to, so 1 by R can be written by the GV. So what is G? Is the, so this is the resistance, so this will be conductance, right? So resistance units are ohms, so conductor means 1 by ohms, or we can say Siemens, right? So this is about the Ohm's law and circuit theory. So when the temperature is constant, so the current is directly proportional to the applied voltage, or we can say I is equal to V by R, or we can say V is equal to I by R. So don't ever say V proportional to I, because when you apply current, the voltage will not be proportional to changes, right? When you apply voltage, the current will change proportionally. So this is generally Ohm's law, right? Next we'll see, in the next lecture we'll see the types of elements. So depending on what is the resistance, what is the capacitance, what is the inductance, etc. Right? That we'll see in the next lecture.